Hi guys, welcome back to Physics 110 tutorial 2 chapter vector. Yeah? So this tutorial mostly is on dot product and cross product of vectors, and also the vector algebra, something like vector summation, vector subtraction, and also the component ijk. Yeah? Okay, we might need to say that split this video recording to 2 to 3, okay, 2 to 3 videos, because the total number of questions I believe is actually quite a lot, 35 questions. So I might need to like split into 3, okay, discussion here. Okay, so look at question number 1. Question number 1 state that number 1, given m is equal to 3i plus 2j minus 2k, and n is equal to 2i minus 2j minus 3k. So what is a vector product? M cross n. Okay, m cross n. So this is a vector cross product. So we start with that. Number 1. Okay, this one is a tutorial 2. Okay, vector. Okay, vectors. And then this one is for physics 210. Physics 110. Okay, physics 110. Okay, so we write down what we are given. Question 1, you have m is equal to 3i plus 2j minus 2k, and then the n, vector n, is 2i minus 2j and minus 3k. So we are asked to find the cross product. Okay, so cross product will be a matrix 3 by 3. Okay, alright, so we start with writing down the matrix first. So we have m cross n. That will be a matrix 3 by 3. Okay, a 3 by 3 matrix. The first row will be a I, J, K. Because it says m cross n, so the second row will be the m component. Yeah? So we have 3, 2, minus 2, and then we have component n, 2 minus 2, and minus 3. And after that, we need to split this one into 2 by 2 matrix. 3 2 by 2 matrix. Yeah? So we have I, okay, and this one is our 2 by 2 matrix. Below I cannot, beside I cannot, so we have 2, minus 2, minus 2, minus 3, and then minus j for the second matrix. So our second matrix will be anything below I, beside I cannot, so we have 3, minus 2, 2, and minus 3, and last one plus k. Okay, so plus k, that means you have 3, 2, 2, minus 2. Alright, so the rest is just to do calculation in solving the 2 by 2 matrix. So we have 2 multiplied by negative 3 minus negative 2 multiplied by negative 2, and this one is our I component, and then followed by minus, okay, the j now. Yeah, so 3 times negative 3 minus 2 times negative 2, and this one is our j, and finally we have plus the last one is for the k, so 3 times negative 2 minus 2 times 2, and that is our k. So the rest is just to do some calculation. So we have a negative 6, okay, negative 6 here, and minus 4. So I have negative 10 I, and this one is minus 3, so minus 9, minus 9, minus 4. So we have minus, okay, here, minus 9, minus 4, minus 9 plus 4. So minus 9 plus 4, you have minus 5. And then minus minus, so you have plus 5 j, and last one minus 6. Again, this one is the same, right? Okay, so we have minus 6, minus 4, so we have minus 10k. Okay, minus 10k. So that is our answer for number 1. Okay, next, number 2. Okay, number 2, find the resultant vectors for the vector shown in figure 1. Okay, we redraw this figure here. So this I will consider as the x, okay, and this one is our y, and then we have the first vector here. First vector I write here. Oh, sorry, this one not long enough. Okay, so this is our x. So now this is our first vector. So since it is a force here, I will call this one F1. Okay, and F1 is 12 Newton at this angle here 70. So if here 70, this one will be 20. Okay, 20, yeah. And then the next one here, this one is 60, so here will be 30. So this one is 18, should be longer. So I'll call this one F2, which is 18 Newton. Okay, 18 Newton, and make a habit so that all the angle is with the horizontal. Yeah? So 60 here will be 30 degree, and lastly this one is 10. Okay, 10 here will be 25 degree. So 25 degree, this one is shorter. So I call this one F3, which is 10 Newton only, and the angle here is 65. Okay, 65 degree. Yeah. Okay, so we know that this is to find the resultant. That means the summation. Yeah, it's easier, okay, to actually split them into components. That means resolve them. Okay, resolve them into components so that it's easier to sum up the value. All right. So we have this. Okay, dotted line. Then the horizontal component, I will use red color. This one also the same component here, and here. Okay, so this one is the F1x, right? F1x. This one here is F2x, and this one here, okay, is F3x. It all refer to the subscript of the force. F1, its component is F1x, F2, its component is F2x, and so on and so forth. And then after that, we have purple color for the vertical component. Alright, so this one is F1y. Okay, and here is F2y. And this one here is the F3y. Okay, F3y. So now everything are drawn. Okay, so the next step is to calculate. Okay, to show your calculation. So now I will use sum up all these ones first. Yeah? So one way to do it is by calculating the component one by one. So our F1x is equal to F1, the magnitude of vector F1, which is 12, and then cosine theta 1. So this one accordingly, 20 is theta 1, 30 is theta 2, and this one is theta 3. So we have here, which is 12 cosine 20, okay, and then F1y will be F1 sine theta 1, which is 12 sine 20 degree. Okay, so our calculation will give us 12 cosine 20, and it gives us 11.3. Okay, 11.3 Newton, and this one is 12 sine 20, and it is 4.10 Newton. Okay, so next we go to the f2. Okay, so our f2x is f2 cosine theta 2, which is 18 cosine 30. Okay, and then our f2y is f2 sine theta 2, and this is 18 sine 30. Okay, so we have 18 cosine 30. This one is 15.6 Newton, and this one is half 9. Okay, 9 Newton, 9.00 Newton. 9.00 Newton. Okay. Alright, so this is our second vector, and finally come to the last vector. Our f3x is f3 cosine theta 3, okay, which is f3 is 10 Newton cosine 65 degree, and the f3y will be the same, f3 sine theta 3, so we have 10 sine 65 degree. Alright, so we have a 10 cosine 65. It gives us 4.23 Newton, and then 10 sine 65. This one is 9.06 Newton. Okay, so we have all three done. All the components were found. Then we have to find the resultant vectors. Okay, so the resultant vector will be just simply to sum up everything. So we have the f resultant is equal to your f1 plus f2 plus your f3. Okay, so the component with the component which are the same only. Yeah? So we can sum up all the components here. So you have this 11.3 plus 15.6, and then plus, oh sorry, I forgot to put in the negative sign. Well, okay, go back again, come back again. So our f1x is positive, f1y is negative here, this one negative, and then our f2x is negative, this one negative, and our f2y positive, and then f3x negative, 3y also negative. Oh, okay, you see, simple thing like that, it kill your answer already. Yeah? Okay, first one, 11.3 minus 15.6, and then minus 4.23. So our I component is negative 8.53, negative 8.53 I, and then the last one, minus 4.1 plus 9 minus 9.06. Right, so we have negative 4.16 J Newton. Alright, so there's our answer for question number 2. Yeah. Okay, this is page 1. Next one. Question 2. Okay. Sorry, question 3. Okay. So our question 3 here. Find the dot product of these two vectors. So we have two vectors given. A. Vector A is 4i minus j. And then vector B is I plus 3j. Okay. So you are asked to find the dot product. Well, dot product is easy. Okay. So A dot B. Dot, that's why it's called dot product. So A dot B, this one is actually the component, okay, AX, BX plus AY, BY. If you got three components, just continue on. So we have 4 times 1 plus negative 1 times 3. So answer is 4 minus 3, you got 1. So the magnitude is 1 only, exactly 1. Okay, it's a scalar quantity, so no problem at all. Okay, So number 3 done. Now go to number 4. Okay, so number 4, given 2 vector again. So vector A is equal to 3i minus 2j, and the vector B is negative 2i plus j. So there are 2 things that we are asked to find. Number 1 is to find A dot B. Okay, so A dot B senang aja. Okay, so A dot B is equal to this one multiply 3 times negative 2 plus negative 2 multiplied by 1. So we have negative 6 minus 2, so we have negative 8. Okay, we have negative 8 for the dot product. Okay, number 2. Number 2, find the angle between these 2 vectors. Well, we need another formula for the dot product. The next formula for the dot product is A dot B is equal to the magnitude of A multiplied by the magnitude of B, and then cosine theta. Theta is the angle between them, so that is the one that you are asked to find. So cosine theta is A dot B, which is already found out, negative 8. And then the next one is the magnitude of A multiplied by the magnitude of B. Now, we're going to find the magnitude first. Yeah? Okay. The magnitude of A is equal to the Pythagoras theorem. Okay? It's either 2 dimension or 3 dimension. Yeah? So our A is 3 square plus negative 2 square. So you have this one is 9 plus 4 square root 13. Okay, we have square root 13, leave it like that. B is square root this one, so we have negative 2 square plus 1 square. Okay, so we have square root 5. Okay, square root 5. So after that we put in here. Okay, so from cosine theta equal to A dot B divided by the magnitude of A and multiplied by magnitude of B. So we have cosine theta equal to this one, negative 8. Okay? Negative 8 divided by this one, square root 13 and square root 5. Okay? So we're going to find out what is that value first. Okay, we have negative 8 divided by square root 13, okay, multiplied by square root 5, right? Okay, so I have negative 0.9923, and then after we find the arc cosine. So the angle is theta is equal to 173 degree. Okay, 173 degree. Okay, so that is our answer for question 4. Page 2. Okay, next one. Question 5. Question 5. So question 5, find the dot product of the vector. Okay, again, vector A is given to be 2i plus 4j, and then vector B is 6i plus 3j. Okay, so find the dot product. Well, dot product is very straightforward. Is it dot product? Okay, dot product. So A dot B, you're going to get straight 2 times 6 plus 4 times 3, all positive, right? Yeah. So you're going to have 12 plus 12, you got 24. So our answer is 24. Okay. Next one, question 6. Okay, 2 vectors A and B have component blah 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 blah. So what is the component of the sum of the 2 vectors? Well, that one is very easy. So number 6, vector A has a component of 0, 1. 0 is the one for the x, this one is the one for the component of the y. Yeah? So we have 0i, we write down first, and then positive, so that means plus 1j. Okay, and this one simplify to become, or just leave it like that. Okay, you can just leave it like that because it's not the final answer yet. B, so our B is negative 1, 3, so we have negative 1i plus 3j. Well, there is a component of our vector. So what is the component of the sum of these two vectors? The sum of the two vectors is A plus B. A plus B, that means you simply sum up the same component, minus I, and then plus 4j. That is your answer. Okay, so if you want to write down the component in the format given like in the coordinate system, that means the component, the sum is negative 1 and 4. See, you can also write down like that, no problem. Okay, all right, so that is number 6. Easy, right? Next one, number 7. Okay, number 7, given that if vector A and B are such and such, find the cross product of vector A and vector B. Okay, cross product. So 7, we write down the vector first. Vector A is 2, 3 minus 2. Okay, 2, 3 minus 2. Okay, and then the B is 3 minus 2, 3. Okay, 3 minus 2 and 3. Correct? 3 minus 2 and 3. 3 minus 2 and 3, 2, 3 and minus 2. Okay, we are asked to find cross product. So write down the cross product formula first. A cross B, okay, is equal to a 3 by 3 matrix. Okay, so we have I here, J and K, and the A is 2, 3 minus 2. This is 3 minus 2 plus 3. Okay, so after that, change it into a 2 by 2 matrix. Okay, and then minus J. Okay, and plus K, last one. Okay, for I is 3 minus 2 negative 2, 3. For J is 2 minus 2, 3, 3. And for K is 2, 3 and 3 negative 2. So after that, we can straight away like multiply this one or minus that one. So we have 3 by 3, 9. Okay, 3 by 3, 9. Right? 9 minus 4. 9 minus 4, you got 5i. Okay, this one, 3 times 3, 9, minus negative 2 times negative 2 is positive 4, so 9 minus 4, 5. And next one, you have minus j, remember there's a minus sign, so now this one is what? This one is 2, 3 is 6, 2, 3 is 6. So since you are 6 minus negative 6, so you have 12. So positive 12 here, so minus 12j. Okay. And the last one is plus k, so it's a positive number to the k, but it depends on the outcome of matrix. This one is negative 4 and negative 9, so you have negative 13k. Okay, correct? Check 2 by negative 2 negative is negative 4 minus 9. Okay, negative 4 minus 9 negative 13k. So that is our answer. Okay. Next one, this is 7. So now number 8. Okay, question number 8. Number 8 is the same like the previous question. Okay, except the vector now is a bit weird. You find the magnitude and direction. Okay, find the magnitude and direction of the resultant vector for the vector shown in figure 2. Okay, this figure 2 here we see. This vector, I will call this vector number 1, okay, number 1, and then this one number 2. Number 2, you look at the arrow, is actually pointing into the coordinate system. center origin. So I will draw it the other way around later. Okay, so it's easier. Okay, like this. So this is our x, and here we need a lot of space here. Huh? This is y. Okay, so we have first vector. First vector. Just now, what color do I use? Okay, black color. Okay, black color first. So we have first vector, which is 10. After that 15. After that 20. Getting longer and longer. So our first vector, I will draw it here. Okay, this one is 10. Okay, this one is vector number 1. It's also Newton. So this one is F1 is equal to 10 Newton. Okay, 10 Newton. And it is perpendicular to the x-axis and parallel to the negative y. Then the second one is 75 degrees. 75 degrees, that means the other side is 15 degrees, so it's quite a small one. And this one is here. Okay, I'll call this the F2, which is 15 meter. It actually points to the origin, so you can draw the vector the other way around. So here we have the angle here. This angle is 75. Okay, we put it there first. Yeah, 70. Sorry, we leave the angle first because we have another vector to draw. Another vector is 20 at 40 degree. If here 40 degree, that means the other side is 50 degrees, so it should be like this. Okay, much longer. So this one is F3, which is 20 Newton. All right. So now we have this angle 75 degree, and this one is 50 degree. Okay, so we check again. F1 is 10. Okay, parallel to negative y, and then the F2, which is 15 Newton, is at 75 degree here, so it's the same as 75 degree the other side. And then this is the 15, and then the third one is F3, which is 20 Newton, 50 degree. Okay, all right. Now there is a reason why we draw all the vector according to roughly the length. Yeah? Because you're not going to draw a vector of 20 shorter than this one. Well, in the calculation it might not cause any problem, but use common sense. Okay, use a common sense, because when you show a result, sometimes the first impression is the most important one. Okay. Alright, so the next thing is we're going to find the component. Okay, the component for each of them. Yeah. So our first one, horizontal component. Okay, the horizontal component for F2 and F3. So we use red color for them. Okay, this one. So this one is F2x, and then the next one is here. This one is the F3x. F1 don't have horizontal component. Okay, and then after that, our vertical component. Okay, vertical component, I use purple color. So this is our first. Okay, and then the F1 itself is the F1y. Okay, and then the second one, this one is our F2y, and the next one, of course, here from the origin until here, this one is our F3y. Okay, so labeling done. The next thing to do is to do the calculation based on all the formula and the diagram. Okay, so I will straight away write down. Okay, F1x. Okay, F1x is 0. Okay, because you don't have horizontal component. But F1y itself is 10 Newton. Okay, and then we have this F2x. Okay, F2x is this one. Okay, this F2x is 15. Okay, 15 cosine 75. Okay, so we have 15 cosine 75. We have 3.88. Okay, 3.88 Newton, and your F to Y is 15 sine 75. So you have here 15 sine 75 give us 14.5. Okay, 14.5 Newton. Right, and this is the value correspond to them. And then our third one is the F3x. Okay, this one is F3 is 20. So 20 cosine 50. Okay, 20 cosine 50, we get 12.9. Okay, 12.9 Newton, and our 3y is 20 sine 50 also. So answer is 20 sine 50, we get 15.3. Okay, 15.3 Newton, but later on we need to change them whether they are negative or positive. Yeah? Okay, check number 1. This one is 0, this one pointing down, so negative. And then for the 2x pointing to the left, so negative. 2y downwards, negative. And then 3x pointing also to the left, negative. And then 3y pointing downward, negative. All negative. Okay, semua negative. So now our F resultant, we sum up everything first, straight away. Okay, 0, 0, this one is minus 3.88, okay, minus 12.9. Okay, so we have minus 16.8 I, and then after that the last one is minus 10, minus 10, minus 14.5, and minus 15.3. So we have minus 39.8, minus 39.8 J Newton. Okay, but this one is not over yet. Okay, because the question asks for find the magnitude and direction of resultant vector for the vector in figure 2. Now this one is another step to go. Okay, we need to do another step. Well, I will extend my answer to the other side here. Okay, so this is our page 3. Okay, so now this is our resultant vector. Now, in order to find its magnitude and direction, we need to redraw the vector. Okay, we need to redraw the vector. Maybe I extend to the other side also. Okay, so we continue the other side. So here we have a vector that is resultant force. That resultant force have a component that looks like this. Okay, so this is our y, and this is the x direction. So we have two components. Remember the red component, I use red color, so we have this one red color. Okay, so that one is our minus 16.8 I Newton, and then another one is minus 39. That one is purple color, minus 39.8, much longer here. So we have minus 39.8 J Newton, and we need to combine both of them back. And the answer is this one. Okay, so that one is the magnitude of our resultant vector, and also the angle here is alpha. Okay, alpha. So we need to do calculation for this alpha and also the magnitude. So the magnitude, I will drop out the vector sign. So now I have resultant, which is square root negative 16.8 squared plus negative 39.8 squared. Okay, so our calculator gives us 16.8 squared plus 39.8 squared. Okay, after that square root, we got 43.2. Okay, 43.2 Newton. That is the magnitude of the force. And after that, in order to find that, we use tangent. Okay, we use tangent. Yeah, so we do it here. Tangent alpha is equal to this one, which is negative 39.8 divided by negative 16.8. Okay, so we calculate tangent 39.8 divided by 16.8. Answer is 67.1. Okay, 67.1 degree.